Okay, so today we're going to do discontinuities, and we're going to sort of explain it as if you hadn't learned what they were, even though this is definitely a topic we review in pre-calculus. So here we have a continuous graph and discontinuous. So a continuous graph is continuous if you don't have to lift your pencil, right? If you don't have to lift your pencil, it's continuous. And then if you have to lift your pencil to keep drawing it, then it's discontinuous. So there's three types of discontinuities. We have a whole or removable discontinuity. Vocab term, right? We have a discontinuity due to a vertical asymptote. Non-removable. And then we have a jump discontinuity, also non-removable. So we usually see these with like piecewise functions. Vertical asymptotes we did last year in our rationals unit, right? Rational functions. And then wholes we did also in our rational function unit, right? It's when there's like an open circle for a whole. These are all vocab terms. So how do we find them? Pretty much we look, so we're not going to look at jump discontinuities, right? Not today's lesson. So today we're going to look at wholes and vertical asymptotes, and to find that we pretty much have to find out where the function can't be. So we have to find values in the domain that the function is not allowed to be. So pretty often this is having our denominator equal to 0. Right, we're not allowed to have our denominator equal to 0. So let's take this guy. We're trying to figure out when the denominator is equal to 0, but we need to factor it. So we're going to factor, right? This one, we have x minus 6, x minus 2. Those two multiply to positive 12, add a negative 8. And then we have x plus 5, x minus 2. So if we look here, we're trying to set this equal to 0. So we're using the zero product property, right? This is a vocab term. So if we set this equal to 0, we have x equals 2 and x equals negative 5. So if we look at this one, since it's also on the top, this is a whole. And since this one is only on the right, there's nothing to cross out, this is a vertical asymptote. So it should be a review from last year, the rationals unit. So these are the two discontinuities. We're done. Now let's take a look at this one. So the top is already factored. The bottom, this is difference of squares, vocab term. Right? So difference of squares is a squared minus b squared equals a plus b, a minus b. So you have x plus 1 over x squared plus 1, x squared minus 1. And we're not done because this is another difference of squares, so we have to keep going. So you have x plus 1, x squared plus 1. That isn't a difference, right? Difference means like subtraction, so we just keep that the same. And then this turns into x plus 1, x minus 1. Okay, so we can see here if we set these all equal to 0, we have x equals negative 1, x equals 1, and then this one, if we were to set this equal to 0, we'd have x squared plus 1 equals 0, x squared equals negative 1. And that's an imaginary number. So we don't use imaginary numbers right now, so we don't have to think about a discontinuity there. So if we look here, this one crosses off, so this is a whole, and this one is a vertical asymptote. Alright, this one's tricky because it uses calc and dummy variables, but you've done it before, and we're just trying to think about it in the terms of discontinuity. Okay, so we're saying when is tangent of 2x discontinuous for 0 to 2 pi. So if you remember, tangent is the same as sine over cosine. So we're going to write sine of 2x over cosine of 2x. And we're trying to set the cosine of 2x equal to 0. So we're going to use actually a dummy variable. So you have to lose a star, right? Right, we can use anything, but I like to sometimes use symbols to let you see, like, what's the point of a variable. So we have cosine star equals 0. So if we look here, right, cosine, if remember, cosine is x. So it's saying when is x 0? We have it here and here, right? So star equals pi over 2 and 3 pi over 2. But remember, when we change our dummy variable, we have to expand our range. So instead of going from 0 to 2 pi, we're going to go from 0 to 4 pi. So for x, we're using this range. For star, we're using this range. So we have to keep going. So remember, we keep going around the circle. So we have pi over 2, 3 pi over 2, 5 pi over 2, and then 7 pi over 2. Okay, so now we want to go back and solve for x. So we know that star equals these 4 things. So we have star equals pi over 2, but we're trying to solve for x. So, right, we have those things equal each other. So we're just going to make this 2x equals pi over 2. And when we solve for that, right, we divide both sides by 2, we get x equals pi over 4. So when we do all these, we're pretty much just always dividing them by 2. So we have 3 pi over 4, 5 pi over 4, 7 pi over 4. And these are our 4 spots where we're discontinuous. So solved for x, right? What did we do? Just to recap, we had to find in this equation when the domain doesn't exist, when the denominator is 0. We remember that tangent can be written as sine over cosine, so we needed to figure out when is this equal to 0. Since the thing in the parentheses wasn't just a variable, we wanted to use a dummy variable, so it's easier to solve. And then we had to use our unit circle to figure out when is cosine star equal to 0. Once we found the spots where cosine star was equal to 0, we had to go back to our original variable and solve for x. And we got these 4 answers. So, big review from dummy variables last year. Vocab. Right. Hopefully you remember. Alright, and then this one, if you think about it, there's no denominator. If you were to draw this graph, it would look like a parabola, right? And your pencil would not move. So this is continuous, which means there's no discontinuities. So that one's easy at the end. Just making sure you can tell when there's a discontinuity and when there isn't. Alright, so that's it. Make sure you get the practice in. These are really important. This is going to be good review of factoring and then a little bit of trig.